Alrighty, so I am demoing how to run autoprob on one of the sample files that is included with the distribution. This is from an amateur game, and let's see. So I ran this already. I'll show the command line parameters in the metadata. But if you look on the left here, this is the source game. And at this point, we can see there's this group of white stones here. In the game, white played right here, which was a mistake, leading to all these stones dying. White should have actually played here instead to create a living shape. And so autoprob using Katago detected this, and this is at move 175. You can see that's in the title here. And then extracted this problem over into here. Now it's a little bit messy. There's this stuff here, but this is very quick to clean up manually. So the first thing I'm going to do is just clean this up. I'm control clicking on all this stuff just to get this off the board. It's not important. Okay, and then I'm going to clean up the edges a little bit right here. Like there's a couple extra stones. So this is starting to look more like a normal Go problem. Now, what do we see here? So this triangle, this is the last move that was played in the game. This will show up in the final problem file, which is kind of nice because it just shows what was happening in the game. It doesn't really change the nature of the problem, but it just looks kind of fun. These white stones are the ones that are getting killed. They have the little cyan dots on them to indicate that. These darker blue dots on the empty squares show what else is dying as a part of this, or what is changing ownership. If we mouse over this board here, we can see some of the information from the Katago analysis showing ownership values, like negative values are white, positive values are black. So you can see these are very alive. These things are colored too on the board. There's policy, which shows I have it out of 1,000, so the higher it is, the more likely Katago thought this move was just without any search. You can actually see this is usually a mark of a good problem where the policy for the wrong move at 282 is higher than the policy for the correct move. So it means there's something a little bit unexpected about this move being the right move. Generally makes more interesting problems. So back over to the problem board. So the first thing I'm going to do here before creating the problem, I'm going to fix some of the edges a little bit. This is a little bit of a limitation of this whole procedure, but there's a lot of problems with leakage, meaning there's all kinds of moves to kind of force your way out that have to be considered that just confuse the whole process, confuse Katago. So I kind of over-constrain these problems in general, which makes them look a little less elegant, but it does make it actually work. So that's a benefit. So right here, like we can see, like there's no value in white pushing this direction to get out, but it can be a valid forcing move. Like there are sequences where white can actually play here and still live, and like of course that's bad, but it just is so confusing. It's much simpler. We just close it like that without taking a liberty. Just close it off. Then Katago will never try moving here. It won't ever be valid. Similarly over here, want to like close this off a bit so white doesn't try to come out. Also, like at the edges, there's some potential edge leakage with Hanes around here. Also, I'm gonna close off a couple of white moves here that could be used as eye threats. And so like even though they can't force an eye down here, they can force a valid path. So for example, if white plays N1 right now, It's a threat to make another eye here. So if you're saying a problem is any valid solution, any sequence of paths that can lead to a living shape, then these are valid moves in the tree. It's a little tricky how to deal with this at a policy level, but the simplest thing for now is just to make it so we don't even have to worry about it. And probably a simpler thing to do would be just close the problem off here. But problem isn't really, this program isn't great right now at doing that and like sort of cutting off parts of what it thinks need to change. It might work, it might not. It also sort of changes the original a little bit for right or for wrong. It's kind of nice to have these amateur problems and shapes if they're not too crazy. Anyway, so this is how I'm leaving it. So it looks a little over constrained. We can remove that, but it should be fine. So one thing I can do here is fill an empty board, put a couple of very solid groups and corners to make it less likely Katago wants just Tanuki right off the bat. Shouldn't really be a problem with this particular problem because it's large enough that Tanuki is probably never going to be that interesting. But it does just make this whole sequence a little bit easier, and these get removed at the end. They both turn to black, which kind of swings the overall score too much towards black, which actually also confuses Katago a little bit. So I'm actually going to like do this, or maybe even like wait till they're both white. Okay. It'll just make the overall score a little more balanced, and it just generally does a better job of finding good variations in this kind of condition. Okay, so now I'm going to hit this make paths, and it's going to start calculating. So there's a lot of stuff getting printed to the text output right now that can be interesting, can be used for debugging. The first thing it's doing is a relatively deep root analysis at the start of the problem, and then starting to create these paths. We can override a couple of these parameters right here. So the path visits 1,000 is relatively quick. You can make this more to have a more accurate problem, make it lower to kind of move faster. So we can see already it's generating a bunch of moves in this tree, and we can kind of click through. So this is the first move that's correct, and we can see some of these paths that are getting created. It's trying to figure out here how deep to make this tree, like what the problem should respond to test the human that's reasonable but not a waste of time. These are very weird heuristics. They're kind of hard to make precise and perfect, but I've estimated what I think works pretty well for most situations, and they're all configurable in the config file. So we can see this sequence went here. Like that last sequence, is that really testing someone to figure out how to make an eye here? Like, not really, but it doesn't really hurt. We can see it decided this move was an interesting wrong variation here to add, because after there it just figures out how to make all those eyes false. And if we go back up to the top, we can see it's starting to fill in like, all right, here's the correct move, here's the wrong move, which is what was played in the game. It's adding a couple of the wrong variations. Generally, it's looking at things like what's a high policy, what looks like a reasonable move without a search as good starting points. It's looking at anything that generates a lot of visits. So as it starts to explore in its tree search, what it focuses on, those also get added to the tree. There's also a couple heuristics like just kind of looking at all the squares that are changing ownership in here, and a couple other things to find good starting points, because you want to kind of have a broad root at the base of the problem that tries a lot of things. These squares here that just show up, those represent places, moves that are added to the tree later on. It's just a way, those all get removed at the end when the problem gets exported, but it's just kind of a nice visual way to see like what part of the board is being added to this tree as these variations are added. If you start to see these squares like creep out in here, it means you've got leakage and there's probably something really bad happening. When we mouse over this stuff, we can see down in this blue box at the bottom, can't put the mouse there, but you can see more information. This is all some of the feedback from Katago's analysis, so we can see things like the ownership values, the prior, which is that policy, it's what Katago calls it internally, the score, which isn't really used much but can sometimes be interesting, things like that. The standard deviation is some kind of indication of how volatile this position is, how volatile the life and death status is, which can be interesting to look at in terms of figuring out where to end things or search things, where you might need more visits. So it's just merrily going along and calculating, adding more variations. And when it's done, these two buttons will switch a live status, so stop will be disabled and make paths will be enabled again. So right now, basically just waiting. You can see some of these variations are getting added, so like this is a mistake. Okay, I don't know why it's not coloring the responses, but so that's the refutation. So if the solver tries here, Katago says this is the best refutation, and there's a couple of human variations after that. If it tries that, it does this move, which has the nice mi to connect out. If it tries this, which was the original correct move, then we make a false eye here, and there's no way to get two eyes. But generally, this is looking pretty good right now. This looks like it's going to make a good problem. Sometimes when you start running it, you can see things kind of going off the rails, and with leakage, or maybe it turns out there's actually like 5 different good starting moves that you didn't realize, or the variations get super deep, or other things that like are just going to make a bad problem. It just kind of takes some experience to run it correctly. So it's adding some of these other basic variations right now. And there is so much stuff in the configuration file that can change a lot of these options. A lot of it's just kind of heuristics that I've added with basic testing. I don't even know if they're great or right. They should probably be played around with a lot. But we can see like all these basic starting moves are getting added. Some of them have very low priors, so you can see like this position here only had 3 out of 1,000 as a prior. Like just a really bad idea, Katago thinks. But it's still good in my experience at Edge of the Tree, because people really will try that. I mean, at a certain level, that's a logical move, right? You start by pushing in from the outside, so it's like a good first policy. Okay, and we are done. So we can see like every square in here got added as a good first move, which is good. It's generally kind of what you want. Even if like you look at this tree and you can see most of them are just one variation long, one move long. It's like you try one thing and you failed. That's better than having nothing at all. It's kind of frustrating when you try a problem, you click the first move and you just get wrong without any kind of refutation. Even a single move as a refutation is a lot better than nothing. So there is one move in here. Okay, so this is one interesting scenario. This is a starting move, is literally so bad that it means that that white is dead in Gote. And since white's dead in Gote, it's like, okay, might as well play somewhere else. You might be wondering why here, like this doesn't look like a particularly good move. I do actually limit it so you can only, Katago can only consider moves that are next to the problem. So it really couldn't play like in an open corner or something because it's just not allowed to. But like there's certainly no point in playing inside if white's already dead in Gote. Now, before adding this problem to goproblems.com or some other site, I would actually probably delete this variation. It's like such a bad starting point. Like, I don't even think you need to add this. And with the like response being dead and gote, it's like probably not even worth adding. Like the second best approach might be actually deleting this move and adding a comment to here saying dead and gote. In general, you always want to end variations um, on the computer response. If it's a wrong variation, this is the one counterexample I think is when the solver dies in gote. But overall, this turned out well. I guess there's a couple others up here. Okay, so this is also dead in gote. And it's like, you're dead in gote. Prove you can live. Nope, you can't. I would probably do the same thing on this one too before adding it. But overall, when you look at this, this is a pretty good problem. We didn't get massive leakage. We have a couple things out here. All the key starting moves seem to be handled well. It's nice that there's only one correct starting move. I'm not personally a purist where I think all problems have to have a single correct starting move, but generally, like, the fewer, the better. Sometimes you'll start a problem with this system, you'll think there's only one starting move, but by the time you've transposed it over and you do a search, all of a sudden you realize like there could be like 8 good starting points. So like, that's probably not the best, and I just abandon those at that point because it's ridiculous. But everything looks pretty good. So my next step would be opening this in an SGF editor and pruning these variations a little bit. The SGF, if you click this, it'll get printed to the text output, standard out. Also by default, it writes an SGF file to the disk called autoproblem.sgf. So either way, that's the output. Print source just prints out to the output what file this came from, which is not interesting in this scenario because we purposely open this file. But if you're doing a directory search, iterating through thousands of files, then being able to refer back to it is just kind of convenient. So that's one example of how to basically run this kind of crazy tool. The last thing I was going to comment on. So most configuration parameters are set in the config file, overridable from the command line. There's just 2 here I've added to the UI because they're maybe super common to want to change in runtime. So one is the max depth. This just basically says, hey, don't let the tree go deeper than this number. 32 is deep, but like you're basically never going to hit that, or you never should. But you might just set this to like something like that when you're making a problem, just to make sure that the variations don't go super crazy. It's better not to if you don't have to, because then it can kind of figure out where it thinks the variation should stop, but sometimes you just want to override that. Path visits, this just tells Car2Go how many visits to spend on each position as it starts to explore the tree. The more you put there, the more accurate it'll be. It can make mistakes if you have too few visits. I've generally seen 1,000 work pretty well for this 15 block weight file, but I have seen every once in a while a mistake, so it's kind of a balance on speed versus accuracy. And I think that is it. You can hit this button again and it'll redo everything. I'm not like 100% that works great, but it might work. Alrighty.